Hey, bonjour, everyone. So we now move to Professor Michele Linardi. Michele, he's a professor, assistant professor at CY since September 2021, and he teaches computer science and programming at the MMI department. And he's a researcher in machine learning and in natural language processing at ETIS laboratory. Please join me to welcome Professor Linardi. Thank you,
Demetrio. Well, first of all, thank you very much, Demetrio, for invitation. I'm very glad to be here today presenting some. It's the first time that I'm presenting both what I teach and the research that I'm doing with my colleagues and in the team headed by Vasilis. And it was really nice because when Demetrio invited me, he put me in front of a dichotomy: the problems and the risk, the opportunities and the risks of using generative AI like ChatGPT vis-a-vis concerning problem like intellectual property rights, security, and so on and so forth. And this dichotomy is crazily actual, interesting in our research in many disciplines that has a relationship with AI. And today I'm focusing on possibilities, right? Maybe I'm too over-optimistical, but yeah, I will try to give you some objective points. And in my teaching in the pedagogical methodology that I use and we use at UT here in France, where I teach projects and skills, competencies. This I cannot really pronounce this. Okay, competencies is like skills, right? Project skills are central, right? And we will see why they matters and how AI is a nice fit, right? And what can we learn from doing nice research, right, in computer science? Who I am, but let me go very fast. I'm teaching just this slide to say that I'm teaching computer science and all what is about machine learning, data mining, NLP, and also programming and how to build systems, web applications. I teach students, undergrad students, what is an operating system, what is a network, how computers communicate, and so on and so forth. And I'm also father of two young boys. This matters a bit when it comes to teach, and also the hours I sleep at night maybe could be important. First of all, I love my students, and for plenty of reasons. They are way smarter than me, and the other day there was the graduation ceremony, and this is an excellent time to wrap up and to meet former students to ask what they are doing now. And it's nice because we maintain our relationships and we remember each other, and that's very nice. And I learn every day when I teach to the students, when I see how they learn, the mistakes I make, the mistake they made is an excellent opportunity to scale up and to get knowledge and evolve, right? And I do it also at home with my kids. They are way smarter, younger than me, and even like all the kids of their generations. And it's good to be surrounded of people that learn, right? At home, at school. So let me outline my presentation quickly. I will jump and, okay, I didn't mean to prepare an educational science class, but let me present you several points of our pedagogical method that we are used. And in order to motivate that AI breakthrough is a pretty kind of lucky strike, right? It's something that fits very well and improves our pedagogical methods. And let me also, during this talk, I will present some lessons that I've learned. And this lesson permit me to propose research and recently I was discussing before, I get some funding and some research project that I'm coordinating, some small at CY transfer. So CY is believing in our research and is believing also on the transfer potential of our research. And so that's also something that is motivating a lot. And of course, my goal, I'm computer science researcher, is to design generative AI. So we open the black box and we would like to learn patterns and to produce, to generate something that makes sense. And this in education, right? At UT, I think that most of you are familiar with the French educational system. UT are University Institute of Technology, are undergraduate programs in France where I teach, and they change uh, pretty heavily, pretty consistently in 2021. Of course, it was right after the pandemic. Many things have changed. Plus, the fact that this undergrad program is span over 3 years instead of 2 years. This is a big change when you have to adapt, especially the former colleagues that were used to teach in 2 years. But there has been also an important change in 3 years. Okay, the students is a curriculum, is an undergraduate program with the objective of a lot of professional objectives. So students are there because they want to learn how to do a job, and they learn in a really professionalizing environment. I will explain a bit. And this at the central part of the pedagogy for the BUT, University Bachelor of Technology, is based on the competency-based approach. So you can think that, okay, the goal, the unit of teaching is the skill. Students are evaluated on how they learn a skill. Skill that we will see that we can define as a savoir agir. In French is excellent. We have all these words, savoir-être, savoir-faire, savoir agir, savoir tout court. And so in English, for the first time, it's not so easy to translate it. I translated, I don't know if it is the best translation is know to act. So a skill is I learn something, some fundamental notions, and then I know how to apply in a professional environment, in a context that requires to produce something, right? And I will be at the school evaluated on how well I do this job, right? And we build it through authentic situations. We need to simulate those, or in the best case, we need to concern industrial actors and build these situations at school. And so we have a strong link with the industry, right, in our pedagogy. And the man behind this is the professor Jacques Tardif. He's a Canadian professor from Quebec. He's an emeritus at the Sherbrooke University. He's one of the author of many seminal works in educational. He's an educational scientist, and he's the superhero, let's say, the one person that proposed the application and the implementation of competence-based learning, right? Approche par compétence. And the Ministry of Education, when it proposed to the teachers and to the schools and to UT, this kind of pedagogy, it keeps into consideration all the theory and all the guidelines that this kind of educational scientist proposed. And basically, the first things that we can say that, okay, we need to define skills, competencies, right? Savoir agir. This is central. This savoir agir is non-automatable. It's something that cannot be automatized so fast. And here, if we start to think about AI, maybe we can think, okay, let's challenge AI. Let's find something that cannot be done with AI. That is already a first way that how we can think, right? And then we have to think that these skills, this competence is mobilized in a family of situations, right? And we have to prove that we can have this skill, we acquire this skill through actions and plus proof justifications, right? This is competence-based learning in a nutshell, right? Let me give you some example in computer science. This morning, Vasilis gave you a lot of nice examples in physics, in machine learning applied to physics. And basically, let me do some example very related to my pedagogy in computer science. A complex actions can be develop a complex system, right? That requires to be like a web application, a web portal, right? That requires a very strong front end, a robust data management system, and a backend, right? And so we want to build full stack systems, right? That require to be maintainable, scalable, robust, so dependable. Simple actions, then we can break down and consider several different simple actions in this complex one. Basically, in computer science, then we study how to define several data engineering problems, software engineering problems to design, to think and to tackle challenges that rise up in a specific application. UI, user interfaces and user experience are crucial, right? We are studying how to develop an experience, how to develop ergonomic interfaces and to test, and also to multiple DevOps operations to put in production our work. And we see that we can consider this pyramid and arriving at what we teach to our students, considering a very complex action that will define our competencies. So I talk about situation. In French, we call the situation d'apprentissage d'évaluation. Those are the new name, let's say, of projet tutoré, or university projects, right? Students have 20-30% of the time have typical traditional classes where they learn, professor teach notions, fundamentals, and from the literature, right? And from giving also practical examples. During this situation, we want to simulate, and in my case, let me just explain to you how I do and how many colleagues push me to do in that way. I invite industrial actors, right? I invite managers, startuppers, and so on, that give me problems, real life problems. They struggle, they have no money, they want something very well done yesterday. And I try to invite them. I ask them to explain these challenging elements to students, and students start to work and start to learn. Of course, I cannot do it directly. It needs a bit of preparation, right? Because the situation still need to be simulated, contextualized, right? And we need to that the students judge, make some choice and explain, right? The student requires to autonomously learn and to prove that he learned some skills, right? So, and also this, I put it in red, it needs to prove this, and this is a guideline proposed by Jacques Tardif. It requires to include explicit references. Researchers are pretty used to do that. We cite, we position ourselves on a state of the art, right? Students can do the same. I push my students to do the same, to have this scientific approach. But now there is AI, right? They should, in a way, be explicit on how they use and which AI they use, right? In this situation. And so that's why we need to prepare and to arrive to a cahier de charge, to a list of functional problems, functional needs that allow students to learn and to put in practice. And I'm pretty proud to say that many projects that I coordinated, and thanks to my students, of course, they got in production in real world industry, right? And this is pretty motivating also in my daily life teaching. Let me define, of course, Vasilis did it in a very, very good way this morning. I consider mainly when I talk about AI, I consider LLMs, generative AI, basically LLMs that integrates an agent, right? That is like a bot that answering and producing content that we ask, right? And prompting on the other side is the way a student, a person can interact with this generative AI. And generative AI has been proposed for helping human thinking, create, and work more efficiently, right? This is needs not to be a shame for students. AI is not cheating. AI is not breaking rules. AI is a possibility to really learn something quickly, more efficiently. This morning I was watching some YouTube videos, some presentations, and from Jacques Tardif. Yeah, coming here, it helps me to revise a bit. And Jacques Tardif put the accent on the fact that we are permitting people to become not more intelligent, but more smarter, right? We can do it quickly. And yeah, not everybody has this opinion, but I think that there are multiple objective elements that allow us to think that this could be the way, right? So, the advent of AI is a paradigm shift trigger for sure. At the school, after generative AI is available, multiple things have changed, especially for teachers that are required to completely reinvent the way they evaluate students. Right? We cannot give any more a code assignments and evaluate undergrad students on this because, yeah. LLMs are excellent in producing code, right? And code that compiles and execute correctly the things, right? And but in CBL, in competence-based learning, AI is not a paradigm shift trigger. AI is an accelerator paradigm, and for students and teachers, this is pretty different. And basically, AI is pushing us to improve the way we teach, right? And this is an opportunity. That's why I was talking about Lucky Strike. Of course, we need guidelines. We need to adapt, and still, the paradigm shift is there. I have a lot of colleagues that I meet regularly during lunch. And we talk about AI, and many of them are reluctant, and I completely understand their points. I don't go against them, but at least I try to set up a discussion, and still there is a paradigm to shift. And basically, why is improving AI is improving CBL? Basically, okay, supporting exploration and critical thinking. This is for free, but it pushes students to give justifications and transparency, right? AI is there. Students must critically think about how we justify some content that we produce, how we are transparent, right? And this is what CBL requires. You are learning autonomously most of the time in a real situation or simulated, and you require justification and transparency. AI is pushing towards this sense. Metacognition. How did I use AI? Did I prompt it right? Did I use the right AI? Is there a plethora of models? Did I choose the good one? Metacognition is fundamental in CBL. And of course, AI is pushing students, even the students with difficulties or students that have low motivations, that is pretty normal. AI promotes the students to be autonomous because they have this feeling of being able to do something, maybe in a way that is not the proper one, but it gives you it augments this sense of autonomy. Then, of course, it's the role of the teachers to understand how to adapt this and to help students, right? And yeah, let me just quickly go on what Jacques Tardif told us concerning transparency. Transparency means to say which AI tools were used, and these are, after all, is what also conferences and journal where we publish, where we submit our work is asking now. also researchers need to have this degree of transparency. Still, the guidelines are not, in my opinion, are far to be perfect, but at least there is this effort ongoing. The students needs also to say what AI contributed on, and basically what AI permit us to do. This in computer science and programming is crucial, as in many disciplines. But for instance, if I say that the AI contributed to implement a search algorithm, right? Search in computer science is a problem that is pretty standard, right? We know algorithm, we know complexities. If we ask an AI to implement in a programming language a research in a big space, this can be done. And if the students understand that AI was the nice tool that gives us a nice algorithm that runs and is scalable in a very short time, this is something that is pretty good, right? And also understanding what could not have been produced without AI, right? For instance, in programming, when we are building a system, it's rare to have AI that thinks about in a very complex application, how to make it maintainable, robust, dependable, how this product serves and solves the needs of our client. This may be trickier and requires to be critically analyzed and requires to set some limits on AI, right? So Jacques Tardif said we definitely not need to ban AI, but we must propose a news that explicitly and that we must favor reflection, right? This is the paradigm that in which I teach and I lucky to be. Of course, the role of the teacher, we cannot, let's say, we need to raise the bar of attention. We need to maybe to do some extra work. First of all, I was saying we need to design situation, right? And we need to invite industrial actors. We need to think, okay, is this project right, good enough to be proposed to the students? Is it difficult? Is it too easy? And so on and so forth. We need to adapt. We need to, first of all, support reflection. So we need to reflect ourselves in advance and propose nice questions and setting clear rules, right? And this is very hard and guide students at the end of the day. And one important thing that, okay, this is probably out of my experience. The important thing is that, and this I really appreciate my educational scientist colleague that taught me a lot on this. Student motivation is a pillar, right? When we teach in class, okay, it seems pretty naive like as a statement, but if we consider what motivation is something that is dynamic, not fixed. Maybe Monday morning is not a motivating day, right? A student can wake up not motivated. What I always observe that the session right after lunch, most of the students are not motivated at all, and it's something that require an adaptation, require reflection from the teachers, right? And this is normal, right, for a human being. And so promote active participations, real to real situation can be a boost, right? And this AI is an accelerator, right? And the way CBL is conceived and proposed from educational scientists is something that consider motivations. And meaningful, authentic tasks do pretty well the job, right? And the goal is shifting from external rewards. Of course, when there is an external rewards, money, economical rewards, good grades, achievements, things that we can put like medals in our portfolio, in our CVs, those are completely normal, are external rewards. We need intrinsic engagement. We need to have rewards every day, and the students must be driven by these rewards. And these rewards is this loop in between motivation and the sense of learning something that is critical and that can be applicable, right? And this CBL is probably one of the nice paradigms to teach. And for reinforcing autonomy, if you are used to the French educational system, most of the master program, undergrad programs nowadays in engineering schools and also at the university are information in alternance. So there will be always a period where students join companies, right, and required to directly in the context of their curriculum and their study path, they need to prove that they can apply before to defend their degree. They need to apply in a real life, and this reinforcing autonomy, once we get the fundamentals, is critical and it's very important. Let me jump from a bit of these concepts to some quantitative results that I had giving survey to my students. I usually give this survey at the end of the second year when in the middle of the second year, right before they go to an internship usually in a company, right? And students at that time they get enough maturity to be pretty autonomous, and they start to think, they start to critical thinking, right? And this is span over 2 years, almost 50 students, so it's not a big let's say population, a big sample, but still it's pretty, according to my experience, is pretty representative. First of all, the student, we see that almost 90% have already thought about how we use AI. So, in an autonomous way, they are aware. And here the question was, how you prepare a final exam using AI. And they thought about it. 10% did not. This is pretty, okay. We have students that are ready to change the game, right? It's a little more distributed and a little more uniformly distributed, the way that positioning for the students, and to understand basically the goal of using AI when we try to find a solution to a problem. And many of them, basically here is in the context of programming, right? Something that is highly automatizable. And many of them, almost 50%, they have at different levels some critical thinking on, okay, I generate something with LLMs, and this generation allows me to learn and to focus on critical aspects of what I have produced. But half of them, unfortunately, I would say, they just care of producing something that can execute and then fix the problem and find a solution without thinking a lot about learning, right? This is the situation. I think it's pretty, it sticks pretty well to the reality. I see students every day, how they go to the solution, how they reason, and you see that these statistics are pretty fair. And here that the students here, this question was about if you are aware of the possibility to understand better real world and to self-evaluate, right? And to self-evaluate, do a self-evaluation. And because this aspect is central to CBL, right? To competence-based learning. And seems that a pretty nice majority is aware of that we can evaluate ourselves. And this, of course, this is in our curriculum, we have pedagogical activities that ask students to evaluate themselves. And that evaluate themselves is not replacing the students, but is to engage in this critical exercise to judge and to learn in autonomy, right? And it seems that students understand that AI is a tool, is a practical tool for doing that, right? And as I was saying in the abstract of this presentation, I also participate. I collaborate with several educational scientists, professor of educational science, And I collaborate with them in some projects at CY. And in this project, we start and we collaborate with some industrial actors that gave us some nice tools that integrate AI, generative AI. And plus, we can, with these tools, we can analyze and understand how students use the tools, right, for the everyday life at school, right? And of course, respecting the privacy and all the confidentiality, right? And at the beginning of this experiment, these are results that we collect from PhD at the PhD level. So students are pretty highly, yeah, the level of the student is pretty high. At the beginning, there was a pretty high excitation, almost optimal, and the motivation, right? Students feel that is motivating to integrate AI in their activities. 90% of them, and this is pretty in line with the statistic that I showed you before, 90% of them already used, right, AI before to start. And now when they started to use AI and in their activities, we do some controlled experiments, we saw that the real usage dropped to 45%. Half of them quit, right, and gave up. And okay, when there is a a failure like this, not okay, let me call it failure, but when there is this negative result, we can learn pretty many lessons. First of all, we realize that students do not easily adapt. This is interesting because we propose a new tool to the students. It's true that this tool was integrating several well-known model agents and so on that students used every day, but we witness a reluctancy or some difficulties in adapting, right? And this is mainly because UX and UI were not matching expectations. If we need to wait more than 3 seconds an answer from an LLM that is not deployed in a cloud but is deployed locally, and so it takes more time for empirical reason, students are reluctant and quit easily, right? Even if they are PhD students, and so they can understand empirical science, so on. But they need to do it fast. We can understand. Ergonomic problems, adapting to a new interface, a new user experience, instead of opening ChatGPT from our favorite bars in the browser, we need to use a tool. We have the fear that a professor is looking after us, right? Is analyzing our data. And so there are multiple things that pose challenges in our research, even when we need to design such kind of framework. And this was pretty nice to define challenges and to understand how we need to move when we want to design this kind of technology. And this comes my research interest, right? And first of all, I understood, and I am understanding that collaborating with industry is crucial, right? It's impossible to think in nowadays where AI is basically a challenge that is shared in between US and China, where there are the main actors. Like, it's impossible to think that we can stay just into academical research, right? And so, first of all, looking what is out there, platforms, tools, research, because also research, a large majority of the research is in pedagogy and in edtech is done with collaboration in industry. And so understanding what's out there from an industrial point of view is important, even if it's not a methodology that is common in research. We need to position on a state of the art, but here the state of the art requires to consider industry, right? And that's why I'm collaborating with Cogniroute, is a French startup that is proposing a tool for students and teachers that integrates AI and can be a very nice ally in CBL, right, in competence-based learning. And how fundamental generative AI is helping? Basically, there has been a huge effort in this last half decade, in the last 5 years, in combining, as we have seen during the presentation of Vasilis this morning, proposing foundation models, so these generic AI that billion parameters models that can learn pretty many things from data and that can generate quite accurately multiple content in diverse topic, right? There has been also a huge effort in defining knowledge base, right? Like knowledge graphs, okay, not needed to define what a graph is, but yeah, a knowledge graph is trying to connect nodes, right, that are pieces of knowledge that can be knowledge proposed that we know from the books, fundamental knowledge, and so on and so forth. And there is a huge effort because AI must produce accurate and things that are in line with the knowledge, right, the savoir. And of course, a lot of interest has been put on prompt engineering. How we ask questions is crucial here, right? And the AI are sensitive to this. And what we see that there are multiple papers proposing survey, comparison, new models, and so on. But still, what we see is a lack of real world validation, right? And especially because, yeah, industry cannot really go. They are not really at the university, at school. They cannot really collect directly feedback on the ground, of course. And on the other hand, university and schools probably face several difficulties in proposing AI technologies, right? It's still ongoing, this effort. And we need validation, right? And so how this tool performs, how we define metrics that tell us quantitatively if an AI is effective or not. This is pretty missing and is what is motivating us today in our research. Digging down a bit in technical details, basically now the accent and the goal is put on LLM agents that can be auto-reflective, right? They do self-reflections and they can do self-evaluation, right? They can basically correct themselves, their hallucinations, right? If an AI is powerful to produce new hypotheses, right, like Vasilis showed us this morning, an AI could be also producing fixed patches to what it generates on what it generates before, right? And so this is a paradigm, basically a review. If we want to define the operation, an AI, a generative AI, a language model, should be able to review, to verify, and to refine content, right? And this is at the basis of a paradigm that is very well known in machine learning, reinforcement learning, right? An AI is an agent, and the learning concerns a reward when we do the correct actions, right? Now we have to define how analytically, right, how we define rewards in real world settings, right? And this, in my opinion, connects pretty well to the Yann LeCun viewpoint today. LLM reached the point where we cannot improve them anymore, roughly speaking. We need word model, right? And the word model is a model that can understand the context very well, right? And so having an agent that understand very well the pedagogical mechanism, what at the school teachers expect from students and what students expect from the school also, in another way around. This is the real challenge, right? And this challenge is model driven, right? We have to find analytical forms, how to define a loss, an informal learning loss that reduces the error of the model, right? Business as usual, but also is a data-driven challenge, right? We need to go at the school, collect data, understand what the students require, and how the students face difficulties. This is also something that matters. And so that there is this vague of research that is called self-correcting and self-reflective LLMs, right? It's pretty new. Second, and yeah, this is pretty big. I put this table that is pretty talkative. Basically, this is a table extracted from a paper, 2025. Is a survey on educational LLM benchmarking. And we have seen that we have a lot of good news in this table, and we have a lot of bad news, right? The good news is that there are plenty of data. Here, each line is basically a data set that, and those data sets are divided by subject, right? Math, computer science, machine learning, law, human science, writing, reading, and so on. Basically, one task can be writing a thesis, writing an internship report, and so on. So we define a subject, we define a language. This is important. Language is crucial for language models, right? And those data sets have been collected from universities, right? Here I see that the big whales probably have not this directly, at least, this possibility to collect those data. And universities have the power to collect this data. And so data-driven efforts to improve these models are there, right? And it's 2025 effort, right? What we see that is maybe the bad news is that most, and it's pretty intuitive to understand why, most of the content is either in English or in Chinese. That's pretty in line with the AI world, right? And we lack, I mean, in France, still the large majority of courses are taught in French, right? Right, French is a perfect example because it's the fourth. The other day there was this announcement. French is the fourth most spoken language, the fourth most spoken language in the world, and so it cannot be neglected because language often contains details, contains a way to explain things, and so pretending to be translating from English to French probably is not a very well methodology. And so we desperately need to collect data at school, and especially in French. And reliable data that has, of course, okay, on one hand, content, right? Knowledge, savoir, fundamental notions, computer science, we can have algorithms, software engineering, and so on and so forth, till to DevOps. But we need also to show LLMs examples on how the students wants to get the knowledge, examples on how CBL, for instance, competence-based learning, wants to the students acquire the knowledge, because the students have to go through a critical judgment, a critical assessment of his or her knowledge, right? And so AI can help and can really, a generative model can help students in this mechanism, in this process, right? And so we need such kind of examples, and we need to learn from these examples. And especially one interesting thing of this table is that we divided the big problem, we break down in subjects and languages, right? Even though multi-language models are pretty effective, we can see that they perform pretty well. But still, here we have a division, and here there is an effort just to specialize these models, jumping from a paradigm where we have a generic billion parameters model, right, to very specialized models. And this is behind really the rationale of mixture of experts There is this paradigm where we have a big network, right? And where it just a very subspace of the nodes of the neurons are responsible of producing an answer, right? We cannot pretend that a big network has activation everywhere to produce something. There should be experts inside. And so this effort is to produce small models that require also small resources. We don't need anymore to deploy them in a cloud. And so if we think about also sustainability, that is also at the core. Last week, as Vasilis said, we were in Tampere in a big database conference, and also computer scientists are very well aware. There have been many presentations where the sustainability of AI was a concern, right? And we have to think about the climate impact and so on and so forth. And so producing small models that can be deployed locally in our edge device or in our small laptop that has very limited resources, this is a paradigm that is required now, right? And yeah, this is the effort. This effort is there, and I guess that we need to chase toward this direction. So let me conclude. I presented some elements of competency-based pedagogy, competence approach par compétence, and plus the generative AI, the abrupt advent of AI, give us a powerful, constructed a powerful synergy, right? And this is when students engage in authentic tasks, in real world situation, and think critically, also about AI, right? And justify the reason, right? And they take the responsibility for their decision, proving that they learned something. AI becomes so the catalyst here is an opportunity, is positive, and we require to design new models, new tools, new techniques with this in mind, and for building the AI for tomorrow, and that will be used by our kids, of course. I thank you very much for your attention. I would kindly ask you if you have time, if you are a student, it's better, but also professor can find it interesting. If you can take a survey, this will help us to advance our research. It's completely anonymous and confidentiality, of course, is respected, and this will help our ongoing research. And that's it. Thank you very much. And of course, if there are questions,